In our study, we noted that these errors, often human-made, can occur during the dataset creation, subsequent labeling, or corpora adaptation processes. Examples of situations and human behaviors leading to these errors include misidentifying the number of speakers in a recording session, for example, indicating one speaker in a session instead of two, or unintentionally recording or assigning a non-primary speaker in a session, leading to the unmarked presence of a speaker in session. Next, determining or entering a speaker's gender errors. Assigning incorrect speaker IDs or saving session recordings to the wrong directory, for example to existing session folder instead of creating a new one. The process of verifying errors or inaccuracies in the metadata of an analyzed speech corpus could be conducted through listening. This approach involves manually listening to the recordings to determine whether the metadata correctly represents the content and attributes of each audio file. While effective, this method can be extremely time-consuming, especially for large corpora with hundreds or even thousands of recordings and error-prone due to factors like listener fatigue. This is why we introduced a semi-automated method to identify and correct labeling inaccuracies in speech corpora. Semi-automated means that the software automatically identifies problematic recordings for listening verification, and the number of such recordings should be only a fraction of the entire dataset content, significantly speeding up the entire process. We applied this methodology to the Clarin PL Studio corpus using Phonexia software. Our method is founded on the analysis of two distinct types of biometric verification comparisons between pairs of recordings: genuine comparisons and imposter comparisons. Genuine comparisons involve evaluating two voice samples that belong to the same individual. On the other hand, imposter comparisons involve analyzing pairs of audio recordings that originate from two different individuals. In such analysis, we expect that the biometric similarity measure for genuine pairs, those from the same speaker, will be significantly higher than the imposter pairs, those from different speakers. To identify folders with recordings from multiple speakers, where originally there should be recordings from only one speaker, we performed a genuine scores analysis. We selected a representative recording for each speaker and compared it against other recordings within the same speaker's folder. The collective verification results were visualized in a data distribution plot, which was asymmetric and disrupted in negative direction, indicating incorrectly placed recordings. Based on this distribution, we set a threshold marked with a green line, below which recordings underwent a comparative listening analysis against the folder's representative recordings, and incompatible recordings were removed. Bottom plot presents the genuine scores distribution after removing mislabeled recordings. We chose the type of analysis described above because misplaced recordings compared to the correctly placed files represent imposter comparisons. These scores should significantly differ from a genuine scores, facilitating separation. And identified mislabeled recordings were further analyzed to find their original speaker and relocate them correctly. To identify incorrect gender labels, we analyzed no cross-gender verification results. For each speaker, a representative recording was selected and biometrically verified against representative recordings of other speakers within the same labeled gender. We then calculated the average comparison result for each speaker with their same gender counterparts. Outliers with the lowest mean comparison values underwent listening analysis for verification. Our methodology is grounded in the observation that no cross-gender comparisons typically yield lower average results due to a significant voice characteristic differences between genders. Consequently, speakers with incorrect gender labels should contain notably lower values in no cross-gender comparison groups. To find recordings of the same speakers in folders assigned to other speakers, we performed a no cross-gender verification analysis. A representative recording was selected for each speaker and verified against recordings of other speakers within the same gender using the speech corpus with corrected gender labels. Based on the analysis results, recordings with results above the selected threshold were further analyzed to determine if they come from the same speaker or not. During listening analysis, pairs of recordings were assigned one of three labels. Same speakers, indicating the recordings are from the same speaker. Different speakers, indicating the recordings are from different speakers. And not sure label, indicating uncertainty about the origin of the recordings. For pairs with not sure label, three options were considered: deleting both folders, keeping both folders intact, or deleting one of the folders. We chose a middle ground, which is removing the folder with fewer recordings. Pairs of recordings labeled different speakers were kept separate, while those labeled same speakers were merged into one folder. Post-modification evaluation presented improved biometric verification performance with notably lower equal error rate and far FRR values as detailed in the two tables. These improvements underscore the corpus enhanced reliability of speech corpora metadata. It is worth mentioning that the aforementioned inaccuracies stem from the database's originally different purpose. They become relevant only when the speech corpus is used for other applications, such as speech synthesis. To summarize, the upper diagram depicts the example speech corpus content with different types of inaccuracies, which can be verified and corrected using the presented method. These changes include the removal of redundant directories and the relocation of recordings to their correct folders. The presented method has certain limitations that are important to highlight. First, it is a semi-automated method, which means it requires manual assistance both in selecting thresholds and making specific decisions based on the review. This adds extra work that must be done during the inaccuracy verification, and additionally, the listening analysis itself, due to human factors, is also subject to some error and uncertainty. And second, the accuracy of the method is limited by the accuracy of the software used to obtain the biometric comparison score of audio samples. The future work may include enhancing inaccuracies identification by using two or even more biometric tools, introducing more automation in inaccuracies detection and correction, improving inaccuracies detection in low-quality corpora, and automating biometric score threshold selection for auditory analysis. Thank you for your attention.